Okay, so I think I turned on the Bluetooth, and we can take it from the very top again. So I hope you can read this. You probably can't. Dealing with Chapter 7. Oh, Chapter 7. And we're looking for the probability that X bar is in between 7.8 and 8.2. That example number 5 or 6 in the Chapter 7. All right, so we're given the fact that the bell-shaped curve represents the population of individuals. This doesn't have to be a bell-shaped curve. What's important is that the middle value is given to us, the sigma is given to us, and the sample size is given to us. If we remember the central limit theorem, we would remember that the X bars, called the sampling distribution of the mean, also has a bell-shaped curve, always has a bell-shaped curve, with a middle value, first of all, equal to the middle value of the original population, namely 8, with a sigma of X bar, called the standard error of the mean, the SEM. The standard error of the mean, X bar, equal to the original sigma of the population divided by the square root of n. In our case, that translates into a sigma of 2 divided by the square root of 25, which is 0.4. So the amount of spread from average to average is estimated to be 0.4. And to get how many averages are in between 8.2 corresponds to the area under the curve of this bell-shaped curve. This is 8.4 here. 8.2 is half of that, so it's roughly around here. So 8.2 would be going up to this number, and 7.8, an equal distance on the other side, would be 7.8. Now, we want the area between these two pieces, which is equal to roughly, again, from here to a full standard deviation is 34%. This is half of that, but it's the big half, so it's about 20%, and this is about 14%. And the other piece, by symmetry, is also about 20%, so our guess is roughly 40% is the guess based on the picture. Question mark. To get the final answer, not the guessed answer, but the actual answer, we convert this to a Z diagram, which will help us get the areas under the curve, which we'll label Z and then a middle value of 0. That's why it's called a standard normal distribution, and a standard deviation of 1. And the only question is, what does 8.2 correspond to in terms of a Z-score? What does 7.8 correspond to in terms of a Z-score? And then by plugging in those two numbers, we'll then find the area between them. Well, the formula that we know from Chapter 6 to convert from a X to a Z is X minus mu over sigma. But in this case, we're converting an X bar, and technically the mu is the mu of the X bars, which is 8, and this is really a sigma among the X bars. So this is the proper symbol to use. And the 8.2 is the boundary, at least one of the boundaries, 8.2 from the original question. The middle value is 8. This is 0.4, as we said, from this calculation, 0.4. And this, in turn, comes out to positive 0.50. And that's translated geometrically into the area between 0 and 1, which is at 0.5, is roughly here. Likewise, when you plug in 7.8 into this formula and do the calculus, 7.8 minus 8 divided by 0.4 is minus 0.5, which is, again, in this direction, half a unit across, so it will be roughly around here. So the only question is, what is the area between positive 0.5 and negative 0.5? And as you can see, again, we estimate it to be about 40% of the area. This is, it's not exactly clear from the picture. Now, the trick from Chapter 6 of getting areas between two Z numbers is to look up the area that corresponds to everything below 50, which is everything here, and then to figure out the area below minus 50, which is also, you can look it up by and then subtract the big area minus the little area, which we can represent symbolically as 0.50 equals what area. Z of minus 0.50 is what area, and then subtract them, because you want to subtract the big area minus it. So if you look up positive 0.50, I recall from today's lecture it was 0.6910, and the area below minus 50 is going to be .3090, I recall. And by subtracting, no, that wasn't it. Anyway, by subtracting them, we're going to get the area between them, which is 39. I think I remember the answer in class was 38% because I think one of these numbers is wrong. But the point is, the answer to the question roughly is this piece here, the piece in the middle, or the piece in the middle, or the piece of the probability is 39%, or 38%, I think, actually. All right, let's see if this worked, and this will be your first very rough, very sloppy, but hopefully useful